what we want to do first is we want to graph this quadrilateral. Boys, we're going to focus down. We want to graph this quadrilateral, so we're going to plot each of the points. So the first point is the point 4, 1. Remember, the coordinate is x comma y. So you go over on the x-axis, then the y-axis. So I go over to the right 4, 1, 2, 3, 4, and then up 1. And I'm going to label this with Q. And now we're going to plot the remaining 3 points. Point U is the point 7, 3. So I walk over to 7 to the right. 1, 2, 3, 4, 5, 6, 7. And then up 3. 1, 2, 3. That's the point U. And then A is the point 1, 6. So we walk over 1 to the right and then up 6. 1, 2, 3, 4, 5, 6. And D is the point -2, 4. So now I'm walking from the origin to the left 2 and then up 4. And that's D. And now we connect the points in that order, Q to U, to A, to D. I should use my tool. I used to have a line tool. There we go. Hi, this doesn't want to work. I'll just freehand it. Okay, so there's our quadrilateral QUAD. So the first thing it wants us to do is find the slope of the consecutive sides. Consecutive means the sides that follow each other. So are QD and AU, are they considered consecutive? If I say QD and UA, are those consecutive? No, what's the relationship between those? What's the word to describe those? Stella? Well, they look like they're parallel, but we don't know if they're parallel. But what's the word to describe them? Like they're positioning to each other. They're not consecutive. They're what from each other? Opposite? Aren't those sides opposite of each other? Right? So what side would be consecutive to QD? What side would be consecutive to QD? So QD and UA, they're considered opposite. So consecutive means they follow. So what side can follow QD or be next to QD? Couldn't we go QA? Oops. Couldn't we go QA or this works, QA? Or what else could we have done? So we could have done QD and QA are consecutive, or what else? QD and Noah? What can be consecutive to QD? AD. All right, guys. So I feel like with the exception of a couple of kids, everybody else is sort of just staring blankly, checking out. So we are going to go back to our old seats. Jack M, I want you back up here. Yeah.
QU? You were saying QA. Isn't it QU consecutive to DQ?
Oh, yeah. QU and DA are consecutive to QD. To QD. And then Noah, I'm going to have you come back up to your Stella table that you were at before. And then Jack and Jonah, I'm okay with you guys staying there. Sebastian, I'm going to have you come up next to Jack M. All right. So now it's saying find the slope of the consecutive sides. So the first slope we're going to find is of QU. Here's QU. So remember, when we find the slope of something, what we're going to do to get from one point to the other point, we count rise over run. We count our rise over a run. So to get from Q to U, I'm rising up. So remember, rise over run. I'm rising up 1, 2. And then I'm running to the right 1, 2, 3. So I rose 2 and I ran 3. So the slope of QU is 2/3. Okay, now we want to find the slope of UA. So again, that's U to A. So to get from U to A, I'm going to rise up 1, 2, 3. So I'm rising up 3. And then now I'm going to the left 1, 2, 3, 4, 5, 6. So my rise was 3. And my run was a -6 since we moved to the left. And what does 3 over -6 simplify down to? Isn't that -1/2, -1/2? Okay, so now we found the slope. Is there any relationship between these slopes? No. Remember, if the slopes are the same, then the lines are what? Parallel. Good. If the slopes are the same, the lines are parallel. Obviously, these lines aren't parallel. They're touching, right? They're consecutive. All right. What about perpendicular lines? What do their slopes have to be if the two lines are perpendicular, meaning they make right angles? Leilani? Perfect. Opposite reciprocals. But 2/3 and -1/2 are not opposite reciprocals. So is there any relationship between these two slopes? No. So now what we want to do is we want to find the length of consecutive sides. So what we're going to do is we're going to find the length from QU. And if you guys remember, the distance formula tells us distance is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, all under the square root. Now Q had the points 4, 1, and U had the coordinates 7, 3. So I'm going to call U x1, y1, and I'm going to call U x2, y2. And now I'm going to plug in so I can find the length of QU. So when I plug in, it's x2 minus x1. So we have 7 minus 4 quantity squared. Then y2 minus y1. So 3 minus 1 quantity squared. So QU is going to be 7 minus 4 is 3. And then we're going to square that. 3 minus 1 is 2. And then we're going to square that. So now 3 squared is 9. 2 squared is 4, which gives us the square root of 13. Is 13 a perfect square? No. What do I mean when I say a perfect square? Give me examples of numbers that are perfect squares. Jack?
25.
25. Somebody give me another example of something that's a perfect square. Jonah? 36. Perfect. Somebody give me one more example of a perfect square. Leilani? 49. Excellent. So if it's a perfect square, do you have to simplify the radical? Yeah. So like the square root of 25 would be 5. The square root of 49 would be 7 because they're perfect squares. But since 13 is not a perfect square, are we simplifying it? No, we're leaving it just as it is. So now I'm going to go through and I'm going to label this. So QU is the square root of 13. Now we want to find the length of UA. So I'm going to write out the coordinates for U and A. So U is 7, 3. And the coordinates for A is 1, 6. So I'm going to say that U is x1, y1, and A is x2, y2. And now I'm going to find the length of UA. So we have x2, which is 1, minus x1, which is 7. And then in the next parenthesis, it's y2, which is 6, minus y1, which is 3, and both quantities are squared. So we're going to have 1 minus 7 is a negative 6. And then 6 minus 3 is 3. Negative 6 squared is 36. 3 squared is 9. So UA is going to be the square root of 36 plus 9 is 45. So then which one is this? I'm going to label it UA. Okay, so now in the directions, it had said this quadrilateral is some type of parallelogram. So now we want to know, is it anything better than a parallelogram? Our options for being better than a parallelogram would mean it's a rectangle. But in order to have a rectangle, we would have needed the right angles. And the slopes were not opposite reciprocal, so it didn't make right angles. So it's not a rectangle. The other option that's better than a parallelogram is a rhombus. But in a rhombus, all sides are congruent. Are the sides all congruent? No, clearly they're not because they're different numbers. So it's not a rectangle and it's not a rhombus. If it's not a rectangle, it's not a rhombus. It can't possibly be a square. So this is just a normal parallelogram. So we're just going to write a parallelogram. All right, what I want you to do now is I want you to plot this next quadrilateral by yourself, and then I'll come around and take a look. Okay. Once you're done plotting, turn your Chromebook to me, zoom in so I can see your graph. Good, 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 good. Just label your points, Sebastian, the Q, U, A, and D. Good. Good. Okay, so now that we plotted our QUAD, now we're going to find the slope of QU. from Q to U. So remember, slope is your rise over your run. So from Q to U, I'm going actually down 1, 2. So that's a -2. And I'm running to the right 1, 2, 3, 4. So my slope is -2 over +4, but I can reduce that fraction. What's -2 over +4? -1/2. You got it. Now I want to find the slope of U to A. Now to find the slope from U to A, I'm now rising 1, 2, 3, 4, 5, 6. So I'm going up 6 and I'm running to the right 1, 2, 3. So again, our slope is rise over run, which gives us a 6 over a +3. But what's 6 over 3? Isn't that 2 over 1? What is the relationship between these two slopes? -1 over 2 and +2 over 1. Aren't they opposite reciprocals? If the slopes are opposite reciprocals, what does that mean for the two lines? They are perpendicular. So let's put a little star here and write that down. Opposite reciprocal slopes make perpendicular lines. So what does that mean for us? That means where QU and UA touch. So where do QU and UA meet? At what point? Where does QU and UA meet? Don't they touch on U? That means where they touch is going to be a right angle. Now, we said this was some type of parallelogram. What do we know a parallelogram with a right angle has to be? A parallelogram that makes it extra special right angle means it's no longer just a parallelogram. Now it's better. What better quadrilateral has a right angle, Jack? A rectangle. So right now it's definitely a rectangle. Now what we're going to do to check the sides to see if it's also a rhombus. So let's look. We want to now check the length of the consecutive sides. So the point Q has the coordinates -5, 1. And U has the points -1, -1. So now we're going to find the length of QU. Okay, so now we're going to do x2 minus x1 quantity squared plus y2 minus y1 quantity squared. I'm going to call Q x1, y1 and U x2, y2. So we have -1 minus 1. Oh, nope, that's wrong. -1 minus a -5. Sorry, let's fix that. -1 minus a -5 quantity squared plus -1 minus 1 quantity squared. Do we all agree this double negative makes a positive? So we're going to have -1 plus 5 squared and then plus -1. I'm going to do my key change. So that's -1 plus a -1. So let's keep going. So -1 plus 5 is 4 squared. -1 plus a -1 is a -2 squared. So QU is going to be 16 plus 4. So the length of QU will be the square root of 20. Okay, now what I want you guys to do is find the length. So I'm going to go to QU and I'm going to mark it. So QU is the square root of 20. Now I want you guys to find UA all by yourself. So just to recap, the coordinates for U are -1, -1. And the coordinates for A are 2, 5. So I would call this x1, y1, and this x2, y2. And while you do it by yourself, I will do it on the board. All right, how many people got square root 45? Okay, great. So now that means this was UA is the square root 45. Is square root 45 the same as square root 20? No. So the sides aren't the same length. So all it is a parallelogram with a right angle. So the only name this could be is a rectangle because it didn't meet the property of a rhombus. All right, next one. So guys, I actually want you to try this next one by yourself. So you're going to plot everything. If you get stuck, call me over. I will be doing this on the board as you do it on your own. So guys, for part B, I found the two slopes and they have no relationship to each other. They're not opposite reciprocals, so there's no right angles. Because there's no right angles, can it ever be a rectangle? No, rectangle's off. Anybody confused with how I got either of these slopes? Okay, now let's go on and find the consecutive sides. So once you finish and find both lengths, let's talk about it. I got 5 for both lengths. Did anybody not get 5? Raise your hand if you might have to come look. You got 5? You good? Everybody got 5? So what does that mean? These consecutive sides, the sides that are next to each other, are equal. In a parallelogram, the sides that are next to each other are not equal. What parallelogram has sides that are equal? What do we call that? A parallelogram with equal sides. It's not a rectangle, or equal consecutive sides, I should say. A rectangle has the right angles and the consecutive sides congruent is a rhombus. So this is a rhombus. So when you're doing these problems and you find the right angle and only the right angle and the consecutive sides are not congruent, then it's a rectangle. If you're doing these problems and you don't find the right angle, but you find that consecutive sides are congruent, then that parallelogram is a rhombus. Any guesses on if you find that that the parallelogram has right angles and consecutive sides are congruent, what it has to be? It would have to be a square, exactly. So I'm actually going to tell you, you don't have homework tonight. We're going to do this homework in class next time in case you need my help. So we will stop here.